Welcome and hello. This is a video exercise in HEC ResSim. And in this exercise, I'm going to do an exercise on scripted rules. This is part 2 of the scripted rules. So there's already been one exercise. This is the second one. What I have up on the screen is a brand new instance of HEC ResSim version 3.3. And we're going to go ahead and get started. First, select the reservoir setup module and then click File, New Watershed. Give that watershed a name, and then select the location that you want that watershed directory to be created in. All right, the units, the time zone, and then apply and click OK. All right, so the watershed has been created. Let's go ahead and sketch in stream alignment. I'm going to click the stream alignment tool here, hold down Control, and then just give a few clicks. Continue holding down Control, and then let go of Control, and give the stream alignment a name. All right, I'm going to click the computation point tool, hold down Control, click on the stream alignment, give it a name, reservoir, then I hold down Control, click on the upstream end, and then let go of Control, click on the downstream end, then give the reservoir name, and I'm going to add one more computation point at the downstream end here. All right, next I'm going to create a configuration. So I'll just go configuration new. I'll just call this config 1. This is how I set up a lot of my videos, just to hit apply, okay, and we're good. Let's go ahead and save the watershed, and then select the reservoir network module in the top left. All right, first we got to create our network, which will be based on that configuration. So I'll select configuration 1 here, and then network 1. Okay. Next, I'm going to click this reach tool here over on the left panel. Hold down Control, click on the upstream junction, and then let go of Control, and then click on the next downstream junction. I'll do the same thing for this reach that's downstream of the reservoir, and then it will save the network. Okay, so let's see. Next, let's go ahead and assign local inflow to this reach. So I'm going to click on, I wanted to assign it to the junction. So click the junction tool or the pointer tool, and then right click on the junction, edit junction properties, local inflow tab, and then I'm just going to call it inflow at CP1, and then factor of 1, apply, and OK. All right, I'm going to go ahead and prepare that inflow right now. It's going to be in CFS, and it's going to be a time series during the month of May 2024, an hourly time step. All right, so I'm going to go up to Tools, HEC DSS View. I'm going to go File, New. This will create a new DSS file. I'll just call it Time Series Data. Okay, the file's been created. Now I'm going to go up to Data Entry, Manual Time Series. So I'm creating a new path here, or a new record, and then I'll fill out the parts here. Location, this will be flow. The time interval will be 1 hour. That's fine. And I'm going to say 2K to 5K from May 1st, 2024 on an hourly basis. CFS. I'm going to paste in the values here. So one moment. Okay, I'm going to go Control V to paste. And hold on. V, there we go. So I pasted in the values here. It starts at 2000 CFS and then it ramps up to 5000 CFS and then back down. Okay, I'll show you what that looks like here. Okay, so here is the sketch of the inflow at CP1. So it's just going back and forth between 2000 CFS and 5000 CFS. So you can create a similar inflow if you want to follow along. Okay, so that's good. I'm going to close that up. Next, let's go ahead and edit the reservoir geometry. So I'm going to click the reservoir tool here and then right click, edit reservoir properties. I'm first going to click on pool and then select the first cell in elevation and then paste, Control V. These are data points that I had saved. I created over in Excel and then I highlighted it and copied to my clipboard. So I'm just pasting them in here. If I click apply, I see the plot show up on the right. The top elevation is 1500 feet. And we're also going to use a guide curve elevation of 1480 feet. So those are two elevations to keep in mind. Over on the dam, I'm going to type in that top elevation and then just make up some top length. So we're good there. Next, I'm going to create a controlled outlet right here. Next, what I want to do is come down to edit gate settings, and I want there to be multiple settings for what percentage the gate can be open. So as opposed to totally open or totally shut, I want it to be open. Have the option to open 20, 40, 60, 80, or 100%. So I'll type those values in there and then click OK. Now let me widen this view a little bit. Okay. Now I'm going to paste in the values that I had saved over in Excel. So here they are. And as you can tell, as the elevation increases, the flow rate, the maximum flow rate through the gate increases as well. And if the elevation is the same, then that flow rate increases as the gate increases. So basically the numbers here increase as you go down and to the right. All right, we're going to stick with one gate, and that's good for now. I'll click apply and then head over to the operations tab. So the first thing to do here is click operations set, new. We're going to create an operation set, operation set 1, then OK. The flood control zone, I'll just set at 1500 all year long. Apply. The conservation zone will be 1480. And this is going to serve as my guide curve elevation. So ResSim is going to try to maintain a water surface elevation of 1480 throughout the simulation, which is the month of May 2024. All right, so this looks good for now. What I'm going to do is just run a base case, which does not have any rules, just to give us a starting point. Then I'm going to come back here to this zone rule tree on the operations tab and add some scripted rules to show you what we're planning to do with this exercise. All right, so for now, I'm just going to click OK and then create an alternative. All right, so alternative, new. I'll just call it Alt1. Enter. The time step will be 1 hour. Operations, I'll select operation set 1. The look back period is going to be the pool elevation will be 1480. That's the guide curve elevation. And then the look back release from the controlled outlet will be 2000 CFS because that's what the inflow is starting at. All right, time series is the last tab. So what I do here is I select this record for that inflow at CP1. This is where we make that assignment. And then click this select DSS path button. Next, I'm going to navigate to that DSS file, which should be wherever you saved it. And then OK. Here's the record. So I'm going to click this set path name button. Boom. And then when I did that, it populated this record and made that connection. All right, so I'm going to go alternative, save. There are a number of other options in this alternative editor dialog box in different tabs, but we're not going to deal with any of those right now. And I will click close. All right, let me just save the network and then save the watershed and then select simulation from the dropdown, the module dropdown. And let's create a simulation. I'm going to call it simulation 1. The start date will be May 1st, and it will be the second hour of the month. The first hour will be for the look back period because we don't really need much of a warm up for this simulation. Everything is at steady state, and the simulation will go till the 31st of May at the last hour. I'll select Alt1 for my alternative and click OK. All right, our network appears in the main section of the box, and we are going to compute alternative 1. Let's see what happens here. All right, looks successful. Let me right click on the reservoir and click plot. All right, cool. So on the top plot, we see the water surface elevation, and then the inflow is in the bold line on the bottom, and that is actually equal to the outflow. So it's the exact same. What I want to do next is take a look at that percent gate opening. If I go up to tools, HEC DSS view, and then I go up to percent gate opening, and I look at the data, we see that the gate opens from 20 something percent to up to about 90% and back down. And if we look at the actual data, then we're seeing 20.3846. And of course, it opens up to 30.8741% open. And then the gate is 45.0847% open. And when I first came across this data, it kind of struck me as odd and even unrealistic because, I mean, how can you really open a gate to that level of precision? And, maybe modern technology has come this far, but for the most part, like the older gates, you're probably going to turn a crank and it's going to lift up 7.5% or 12% or whatever every time you do a crank. So in this exercise, I want to write a scripted release rule to make this a little bit more realistic and say, for instance, that a gate can only open 10% of the way. So instead of 65.0618, you may be actually open the gate 60% or 70%. And I'm going to write some logic to make this operation a little bit more realistic. All right. So let's go ahead and close that. Close that. I'm gonna make a trial based on this alternative, and I'm gonna call this script no tolerance. So you'll see what that means, but it will have the script rule. Okay. Okay. So I'm gonna right click, edit run, reservoirs. Now what I have here is my operations tab, and I will right click, add new rule. I'll call this script controlled outlet, and it is a script. Okay. So it gave me the code. I'm going to right click and add to all zones before I forget. All right. So at the top, we have our imports and our modules included. Then we have our function to init rule script. And then the main function here is run the script. So this happens once at the beginning, and then this runs once per time step. And then it returns an OP value. All right, so what I'm going to do in this exercise is type some code, but I'm also going to paste in a lot of code just to save time, and it makes more sense. So, I don't do typos, and I can focus on explaining rather than typing. Okay, first I want to scroll down to where it says add your code here in the rule run script method. I want to get the current guide curve elevation. Now I know that's 1480 feet for the entire month, but in some situations it might not be. So I want to read that in from the network itself. The network, of course, is this second parameter here that's passed in. So we have access to that data. I'm going to call it guide curve elevation time series equals, and then I'm going to come over here to network. Oops, sorry. No, model variable, reservoir 1. Then let me make this a little bit wider. I want it to be it's the conservation zone elevation. So that's this here. So I'm just going to double click and it pops into place over on the right. Now that's the time series. So what I want to actually extract is the value from the previous time step. So that's going to be guide curve elevation time series dot. Then I actually want to get the current value, not the previous value. So I'm going to come over to time series, and then get current value is right here. So I'll double click, and then what this parameter has to be is the current runtime time step. So that's this right here. I will copy that and then paste. All right, so that will return me the guide curve elevation. Next, what I want to do is get the water surface elevation. Now, this will have to be from the previous time step, but it'll be the end of the previous time step. So it's pretty much the same as the beginning of the current time step. And that's going to be from reservoir, this top one here, pool elevation. So make sure my cursor is in the right spot. Double click, boom. So I'll just type water surface elevation equals water surface elevation time series dot. And instead of get current value, I'm going to come down to time API time series, get previous value, put my cursor in the right spot, and then double click, get previous value. And then I will just copy this parameter again. All right. So the water surface elevation again would be something like 1480, but it may be a little bit off. So we could just make up some generic value that's close. We'll say 1480.21 feet. What I also want to add to these is get elevation current and then water surface elevation previous. Just rename those so I can be explicit, remembering exactly what it is. Next, I want to know the maximum release based on that water surface elevation. So I'm going to say max release equals get max release water surface elevation. So what I'm doing here is I'm calling a different function. Before I can get the maximum release, I want to go back to the physical tab of the reservoir. So I'm gonna go ahead and click apply so I don't lose any data here. So that's saved. All right, and then I'm gonna go ahead and click physical and then controlled outlet. And max release refers to the 100% open. So with these elevations of 1400, 1410, 1420, all the way up to 1500, those have a corresponding 100% max release through the controlled outlet of 0 CFS, 1000 CFS, 1900 CFS, all the way up to 5500 CFS. So back over the operations tab, I'm going to create a new function. I'll put it right here. Okay, I'm pasting in that function. and it's going to be called get max release. It'll take the water surface elevation. This right here is a hash table based on the just corresponding that elevation to the max release in CFS. And then it's getting the keys. And basically what's happening here, you can pause the video, but it's going to do a linear interpolation at this step right here, where I have an A and a B, which is like the lower bound and the upper bound based on the water surface elevation passed in and the data in this table here. So for instance, if the water surface elevation is 1445, then the max release would be between 3,400 and 4,000. That's what's happening. And we're returning that max release. Okay, next I need to get the inflow. So I'm just going to paste it in instead of type a bunch of typos. It's just like we did before. I say inflow time series, and then I grab the inflow time series from the time series model variable reservoir one. And then that's going to be flow in is the parameter you're looking for. And I have my inflow current variable. Okay, next what I want to do is write a for loop. So I'm pasting that in here, the unindent, dedent, and then I'm going to say step equals 10. So we're stepping up 10% each time of the gate opening. We're going to say the gate can open 10% at a time. It can start at 0, and then it goes up 10%. We have a flow, up 20%, 30%, and so on. So what this for loop is doing is it's opening up the gate percentage, starting at 0, going up to 100%, stepping up by 10 at a time. All right, so then after that, what I have is a gate opening larger and a gate opening smaller, because I'm going to write a for loop that's going to open it up until the maximum release exceeds the inflow. And then I'm going to basically go back one step, close the gate, another 10%, and then that'll be my lower bound, which is my gate percent smaller. So here we have a larger and then a smaller. And then right here, I have gate percent open larger index. So that's going to be like, if the larger percent open gate is 30%, then this would be 3, representing the fourth index of the array that starts at 0, in which case the smaller would just be 1 less than that, which would be 2 for 20%, which is just an example. Okay, and then these two lines right here basically say what is the release based on that larger and smaller gate openings. So what we have is the maximum release times the percentage of flow of the max release based on that opening. So what I need to do is create a array here for release percentage of max. Okay, and I've done that. I'm going to put that at the very top, so it's more of like a global variable. We'll just stick it way up here and paste. And what this says is the first record is the percent of max that would be released if the gate is 0% open. This is the percent or decimal of the maximum release if the gate is 10% open. So if the gate is 10% open, then it will actually release 22% of the max. If the gate is 20% open, it'll release 38% of the max. If the gate is 30% open, it will release 52% of the max. And of course, at the end, it's a 1.0 because if the gate's fully open, it will release equal to the maximum. So I didn't want to make this linear. That'd be too boring. So those are the numbers I made up. If that's realistic or not, doesn't matter. That's what we're doing for this exercise. So that's what this release percent of max is down in this equation here. Okay, I'm going to give myself a few lines here. I'm going to paste in some more codes. Paste. Okay, that was a lot. I'll show you what's happening here. Basically, it's just 3 separate cases. Okay, so remember, we're opening the gate 10% of the time with this gate percent open larger. So once it loops around enough time and the gate has opened large enough, then eventually this if statement will be true. And that is the percent of water through the gate will be larger than the current inflow. And that's when we have our maximum bound. So that's what's happening there. Otherwise, it'll just keep looping until it gets up to 100%. Okay, so the next 3 if statements here are similar. The first one is if the water surface elevation is greater than the guide curve, what we want to do is we want to increase the releases because we want that water surface to get lower to the guide curve. The next if statement is the opposite. If the water surface at elevation is less than the guide curve, then we want to reduce our releases. And then the last case is if the water surface elevation equals the guide curve elevation, in which case what we'll do there is we're going to determine if the inflow is closer to the lower gate setting or the upper gate setting, and whichever gate setting it's closer to, that's the gate setting we will select. So you can take a look at this code. Basically, it's making that if statement comparison first, and then it's getting the gate setting index, which I don't think we're actually using until later in this exercise. So, but the release is what we want. So the release here would be equal to the larger gate setting. If the water surface elevation is above the guide curve, the release is going to be equal to the smaller gate setting. If if the water surface elevation is below the guide curve, and then, like I said, it'll be either above or below when the water surface elevation is equal to the guide curve based on whichever is closer. And then at the bottom here, I am breaking out of the for loop because we have found the two upper and lower bounds based on the inflow. Okay, I think all we need to do now is specify the rule. So it gives me a default rule here of maximum 1000 CFS. We are not going to use that, so I'll comment that out, and I will make a copy of my clipboard and paste. What I want to type in here for 1000 is just release. And then instead of a maximum, I want it to be a specific rule because we've already done the logic for what we want it to be. All right. And I think that's good. Let's go ahead and apply. So when we click apply, it saves it. And then we can click this compile script button to make sure it's happy and there's no syntax errors. So I'm going to close this and then compute. Let's see what happens. All right, so something ran. Let's go ahead and check out the results and then click plot. Oops, I'm going to toggle off the alternative one plot results. Right click, plot, and then boom. Here we have a constant elevation of the water surface elevation in the top plot. And then the bottom plot looks interesting. If I highlight the green line, then let's zoom in on the first few days and see what's happening here. So it looks like the flow rate is just below 2000 CFS, 1975 for a number of hours, and then it shoots up to 2685 as the release, and then it goes down again. So it needs to do this to satisfy its that guide curve elevation. Okay, so that's what's happening there. This is what happens when you open the gate 20% of the way, and then 30% of the way, and then 20% of the way. A little bit more realistic. All right, then once the inflow increases, let me zoom out a little bit. Yeah, once the inflow increases, what we see is we open the gate a little bit more and a little bit more, but there's still a lot of jaggedness to this operation, what you might call bang bang operation, which is probably not good for the system and overwork for the operators. So this is a good first step. What I want to do is actually plot out the operations. So like before, we could click on the operation rule set over in DSS view. I could go select the percent gate opening. What I want to do now is track the actual percent gate opening based on the operation we just ran, where it was specific. The gate had to be open a certain percentage on a 10% interval, not just any floating value number that ResSim currently allows for. So let's go ahead and make a few changes. So I'm going to close this. What I'm going to do is click OK here. I'm going to go up to edit and then state variables. What I want to do is create a couple scriptless state variables, and that will allow me to track that data for each time step. Let me expand this. Okay, so my first step here is I want to go up to state variable new, and I want to give it a name. It's going to be called gate setting index. Okay. And it's going to be a scriptless state variable. So I'll just click this radio button for scriptless, which means it will be written to, but there's no JavaScript or sorry, Python script that's associated with it. It's not generating its own script. There's no code to it. Parameter name, I'm just going to call it the same thing, gate setting index. So that will be in all caps. And this is part C, I believe, of the DSS path. And then for parameter name, I want it to be unitless because it's an index. 0 representing 0%, 1 representing 10%. Yeah, so unitless. So I can either go with code or count. Those are both the unitless options. And I'll just stick with that. So I'll go save that. And the other state variable I want to add is for gate percent open. So gate PCT open, okay. And then I'll just say the same thing for parameter name, and then count. It's also going to be unitless, and it's also going to be scriptless. So that's all I'm going to do here for state variables. I'm going to click save and then close. Now I'm going to go back over to edit the script. I'm going to go edit run reservoirs and then click on the script. Now when I click on state variables here to expand it, I should see my two state variables that I just created. Okay, so now over in the code, I'm going to scroll down to, here's the run full script. That's good. After the break is where I want to paste in some code. So you could pretend I was writing this code, but I did at an earlier time. What it is I'm writing the gate settings. So I create a variable for the gate setting index time series, and then I'm setting the value based on that gate setting index. And that gate setting index we defined. Oh, here's gate setting index. Yeah, so we have the gate setting index already. And then the gate setting index, the gate percent open is the gate setting index times the step. So we have all of this already. I'm going to go ahead and click apply, rerun it, and then let's take a look at this data. So before we were just looking at flow rates, but what we really want to know is what percent the gate is opening for each time period. So apply, and then OK. We'll close this, and then I'll click run. Okay, it ran. That's great. And then plot. Okay, so we've seen the plot before, but what I want to do is let's take a look at tabulate. Okay, so this is just the flow rates. There's 1 hour where it jumps up to 2,700, then 1975. The water surface elevation here is hovering around 1480 because that's the guide curve elevation over here. See, once the water surface elevation gets above 1480, like right here, then the next time step, it releases 2,700, and then it's back down again. All right, that isn't what I wanted to look at though. All right, let's go over to Tools, HEC DSS View, and then I'm going to select, so this is the file. I'm going to select gate, the two gate ones that I just created. Gate percent open, and then if I click percent, so it's 20% open to start off. And then if I scroll down, we should see a 30% open. There's 30% open right there. And then the next hour, it goes down to 20% again. And then let me scroll ahead to the middle of the month. Yeah, now we're opening it up 90%, 70%, 80%, 60%. It seems like almost every hour it's changing. Okay, here's a few hours of 50%. One thing I want to do is bring in the actual gate percent opening and index in the same plot. So what I'm going to do there is I'm going to right click, duplicate, custom one, just something to remember and use as a filter. So that's gate opening percent. Okay, then let's take a look at gate setting index. Then I'm going to duplicate that, kind of select it first, and then right click, duplicate. This will be custom one. Okay. All right. And clear the filter out here. And then with part F, I'll go custom one. Now here are the two records that we created state variables for and then wrote to during the compute. So I'll click the table. And what we have here is 20% is at setting 2 at the index 2. And then later in the month, we would see 40%. Setting 4 represents 40% opening. Setting 3 opens 30% opening, and so on. You'll see why this is important right now, actually. What bothers me is the fact that this changes so much. Let's go back out to the plot one more time. The water surface is right at 1480, but I think what would be more intelligent is to operate the reservoir in such a way that we allow for a little bit of tolerance. And if we're off a few inches or even a foot, it's probably all right as a trade-off, as opposed to shutting the gates and opening the gates every single hour. So if I go file and then tabulate, it seems like there's a big jump between 1970 when the gate is 20% open and 2700 when the gate is 30% open. So what if we said there was a 5% increments instead of 10% increments? Let's go ahead and make that modification and see how that affects the operations. So I'm going to go into reservoirs and then go into the script. Instead of having these release percentages, I'm going to create one for 5% increments. Okay, so I'm going to paste those in. Basically the same thing. So 0 and 0 are the same. 22% is 10% opening. There's that. 20% opening is now going to be 38%. That's the same. So what I'm doing is I'm just filling in the 5%, the 15%, the 25%, and so on. So it continues the curve, but with a little bit more precision. The other change I need to make is changing the step to 5. That's here. So I'll change that to a 5. So that's a 5. Let me click apply and see what happens. Okay. And then compute. All right. Right click, plot. All right. It looks a lot like what we had previously. Let's zoom in on the first week. Yeah, it looks a lot like what we did, but the max flow isn't 2,700 anymore. It's like 2,300. And then as we zoom over to where the inflow picks up. So I don't know if that really helped our situation of reducing the amount of times we're opening and closing the gates. So yeah, 1970, that's 20% open. Yeah, 2340, 25% gate opening. Next, I want to create a trial and say that there is a tolerance of, say, 6 inches or maybe a full foot to allow less operation of the gates. What I have on the screen here is the results of 744 hours, which is the number of hours in the month of May 2024. We have the 10% gate settings, which is what we ran first, and then the 5% gate settings. Sorry, this is not very well polished, but what it's happening here is the maximum that the water surface elevation got was 1480.1 and 1479.9 for max and min, respectively. And it was even a tighter window when we had a 5% gate setting discretization, and that was 1479.96 and 1480.03. So we're only seeing like hundredths of a foot. And I just feel like we need to give the system a little bit more tolerance and just kind of relax the operations so that we're not changing the gate settings every hour of the day. There was 186 gate setting changes and 243 gate setting changes. So that's basically like 25% of the time and 32% of the time when comparing to the 744 hours in the month. So that's too extreme. That would never be the way that you want to operate a reservoir. I'm going to go ahead and make a new trial based on the first trial. So I'll say new trial, and I'm going to call it script with tolerance. Okay. And then we'll do a right click, edit, then reservoirs, and then operations tab. Make this bigger. Okay, here's the script that we had before. I'm going to go back to 10%. So I'm going to remove those changes that we just made for the 5% rule, but we will be adding the tolerance in. So I'll change the step back to 10. Next, I'm going to go to the beginning of this run rule script, and just below where we create the OP value object, I'm going to paste in a new block of code, which is right here. And what this is doing is it's actually getting that gate settings index. So that would be 0 for 0% open, 1 for 10% open. Yeah, I had to do this try block because we're using the previous get previous value, and the very first value wouldn't have a previous value. So that took a little trial and error. I got ironed out. So now we have this gate setting index previous value. And if it doesn't exist, it'll just be set to 0, which will only be true for the very first time step. Next, I'm going to scroll down here, and just after inflow, but before the step, I'm going to paste in something new. So I pasted in 2 more lines here. This is the water surface guide curve delta. So what I'm doing here, absolute value of that difference is just going to be the difference in elevation between the guide curve and the water surface, or the water surface and the guide curve. So one may be above the other. It doesn't matter. I'm just looking for that difference. And then the tolerance right here is going to be 0.5. So I'm going to start it off at, actually, let's start it off at 1 foot and see what happens. Okay, just below step, I want to give a few lines and then paste. And what I'm doing here is if that water surface guide curve delta is less than the tolerance, then I'm going to set the release equal to what it was in the previous step. If the water surface elevation is within 1 foot, that's our tolerance here, of the guide curve elevation, then we're not going to do any of this for loop business. We're just going to assign the release to what it was in the previous time interval. What I need to do here is create an else, put everything else that I had down in else. So let me just highlight everything here and then indent 1 down to the break and then indent. Okay. which means if difference between water surface elevation and guide curve elevation is more than 1 foot, then we're going to perform the same operation we did previously. So that should reduce the execution time and change the gate setting much less frequent. Okay, let me go ahead and click apply and then click OK and see what happens there. So I'll go ahead and run that script with tolerance and then close. Let's toggle that off and then right click plot. And what we have on the plot here is a similar but not quite the same. So on top, the guide curve elevation is still very close to 1480. We'll take a closer look at that in just a moment. We have the same inflow as before, and you can see that our release is to a certain extent matching that inflow with a little bit of a lag, which is now in green. Zoom in on this action. Yeah, so what happens here is once the inflow is exceeding the release, so at a certain point, this amount of storage extra volume constitutes a 1 foot elevation of the water surface over that 1480. And then right here at the beginning of May 8th, it looks like we open the gates, probably a number of settings, probably from like 2 to 5 or 2 to 6, and then up another setting, and then up a third setting, and then down a bunch. And at this point, we're probably down to 1479.0 or 1478.99, and we close the gates because the water surface elevation is dropping too much. So that's awesome. Let's go ahead and take a look at the numbers. So if I go ahead and click tabulate, so in this table you can see the releases, the water surface elevation. I'm sorry, the guide curve elevation is right here. That's not changing, but the water surface elevation at this time step goes from 1480.8955 to 1481.04. And that's why we see this increase of release from 1,982 up to 3,800. And then the next step is at 4177. So it looks like a jump, like maybe 3 or 4 gate settings here, and then maybe 1 or 2 more, probably 1 gate setting right here. Let's take a look at that in our custom data that we created from using the state variables. So where are we? This is the very beginning of May 8th. All right, so I'm going to close this real quick, head over to HEC DSS view, and then we want gate percent gate open. So I'm going to grab alternative 2 here, duplicate, I'll call it custom 2. Okay, that was gate percent open. And then what I want to do is gate settings. And then let me make a quick copy of this, duplicate. I'll call this custom 2, just so I can find them both in the same filter easily. All right, let me clear this filter and then come over to the part F and look for custom 2. Here are the 2 records that I want to analyze. And here is the data itself. Now let me go down to May 8th. So here we go. Yeah, so it was at setting 2, and then it increased to setting 5, which is 50%. And then it increased after the next hour to setting 6, and then 7, and then 8. Looks like it stays at setting 8 for a number of hours, and then boom, it goes straight down to setting 2. So maybe there could be some room for improvement on that, but based on like maybe the change in inflow or the average inflow change, there's a lot more we could do. But the last thing I want to do for this exercise is show you the results in Excel. So what I did over here was we did the original 0 tolerance at 10% increment on the gate, and then we had the 1 foot tolerance. In a separate exercise, I did a half foot 6-inch tolerance on but let me scroll down and show you the final results here. There were 186 gate changes with 0 tolerance at the 10% gate discretization over 744 hours in the month. So that's insane. And yeah, we could keep the water surface elevation within 0.1 feet. But if we had a tolerance of 1 foot, like over here, then that would result in only 27 gate changes over the course of the 744 hours or 31 days of May 2024. And the minimum water surface elevation would still be close to within a foot. So from 1478.73 is the lowest, and 1481.34 is the highest. And then the 1/2 foot tolerance behaved a lot like the the 1.0 foot tolerance, where that involved 33 gate changes, like 33 hours we had to change the gate setting. And then the tolerance was a little bit tighter. So that's sort of a compromise between the two. But yeah, I mean, 186 versus 27, I think it would make sense for water operators to allow for a little tolerance, either 1 foot or half a foot, in order to reduce the amount of times they need to change the gate settings in the month. All right, well, that was an exercises on scripted rules. You got to see some code and some results and some state variables and put it all together to analyze what a reservoir system can do using some of these methods.